Yeah. Hi guys. Good evening.
Hi, sir. Good evening.
Yeah.
Good evening, sir.
Yes. Good evening. Yeah. Let's start the class. So last class we discussed about the GPIO, right? That LED. Okay. So again, today we'll see the another GPIO that is the push button. Okay. How to use the push button in STM? How to get an input? We'll see both HAL programming as well as the bare metal programming for this um, push button. Okay, so when I press this push button, that LED has to be glow, something like that. We will see. Okay, so I'm just going to open my STM. Yeah. So as we already discussed, we have a push button, inbuilt push button in our nuclear board. Okay, and an inbuilt LED, right? That is PC13, your inbuilt push button, and PFI is your inbuilt LED. Okay. So now I'm just going to create a new project. So for the first project, I'm just going to use my inbuilt push button and inbuilt LED. Okay. So then we will connect an external LED. Then we will see what is happening with that. Okay. So I'm just going to open this MCU MPU selector. Okay. Since I already made a favorite for my board. Okay. I'm just clicking the star icon. Then I'm just getting this nuclear board. Okay, what is this port? This is 103. Not needed. Okay. So this is my F334C86. Okay. So select your board, what board you are having. Okay. Select that and then click next. So this is my push button. Okay. I'll just click push button board. So I'll see the same thing for workway also. Okay. Okay, so now this is my IOC page. Okay, so here I'm just going to configure my push button, my LED, and then I'm just going to configure my oscillator. Okay, so these three things I need to configure first. So first one, my configuration for oscillator is available in the system core. Okay, so I'm directly going to this sys. Okay, the time base source is system tick. Okay, and then this RCC. Here I'm just going to bypass my high speed oscillator and then I'm just going to use an crystal ceramic for my low speed oscillator. Okay. So for sys, I made the system tick as my time base source and then RCC, I selected my oscillators. Okay. So these two things are done. And the next one, my inbuilt LED is actually connected to PFI. So I'm just going to click this PFI and mark it as GPIO output. Okay. And similarly, my inbuilt push button is connected to PC13. So I'm just going to click this PC13 and I'm just going to make it as a GPIO input. Okay, so since my button is an input device, so I'm just selecting it as an GPIO input. Okay, so that's it. One input oscillators, then one output. Okay, so now I'm just going to generate the code for this configuration. Okay, so I'm just going to click on Control S. It is asking, do you want to generate the code? I'm just selecting yes and yes. So my code will be generated for the configuration done in my IOC file. Okay, now in this push button, if you want to make this push button into this open drain or pull down method or pull up method, you can actually able to select it. Okay, for example, if I click this PC13, that is in GPIO. Okay, this is my PC13, right? If I click this, I'll get all this additional configuration. Okay, so if I want to use this as a pull up method or a pull down method, I can select over here. Okay, or no pull up, no pull down, you can directly select it. We can configure it with the hardware itself. Okay, so that is the additional configuration you can able to select it over here, right? Okay. So the code is generated for that configuration. Now you can see over here, here I have this GPIO initialization. If I open this function, you can see this is for my PC13 as an input. Okay, and this is for my PFI, that is for the output mode. Okay, so I have two GPIOs, both for input and output. Now I'm just going to write a code for this. So first method, okay. So initially what we did is we will directly go to this while of one. Okay, so here we are going to write our code, right? Okay, so first we will try with this HAL method. Okay, right. So if you want to turn on an LED, what is an API you will use? I want to turn on my LED. Not toggle, I am going to turn on. Yeah. Okay, we will use HAL underscore GPIO underscore. What is the API?
Written pin.
Yeah, right.
Right pin, sorry. Right pin, sorry.
Okay, right pin. So since your LED is an output device, we are going to write that pin. Okay. So here what I need to do is I'm going to check my push button. If my push button is pressed, then I'm going to turn on my LED. Okay. If my push button is not pressed, then I'm just going to turn off my LED. Okay. So that I'm going to do. For that, we are going to read that pin, right? So HAL underscore GPIO underscore. Okay. So this is and read pin. Okay. Now this read pin is actually asking two parameters. One is which pin or which port I need to read, and in that port, which pin I need to read. Okay, only two arguments. So first one, this is port C and pin number 13, right? So pin capital letter underscore 13. Okay, so this is what an API for reading and single pin. Now what I'm going to do, I'm just going to put an if case in front of that. If this read pin is double equal to 1. That means I'm reading this pin, right? And if it is equal to 1, then I need to turn on my LED, right? So I'm reading a pin, and if that pin is 1, in some cases, what will happen? Your push button will be connected in the drain, open drain. Okay. So that means initially, if you are not pressed, it will be 1. If you press, it will become 0. Okay, so there you need to put something like a 0 over here. That's it. Okay, so this is for checking the status of push button. Okay, So I'm just taking the status of a push button. If my push button is pressed, then I'm just going to turn on the LED. Turn on in the sense, this is a GPIO right pin, right? So I'm just going to write, okay, this port A and pin number 5. I'm just going to set the state. Okay, so I'm going to turn on LED at PFL. Okay, so when I press this push button, then my LED has to be turned on. Okay, or else what should be happen? My LED should be off, right? So else the same thing, my LED will be reset. Okay, that's it. Only 5 lines of code for this digital input method. Okay, so when I press this, if my button is pressed, then turn on the LED. If it is not pressed, then turn off the LED. That's it. Okay, so now I'm just going to build this code and check if there is any error present. So I'm just going to build the project. Connect my board. Okay. So there is 0 errors and 0 warnings in my code. So I'm just going to debug this. Click OK. Right. Okay, so I'm in my debug mode. So I'm just going to press this resume button under this search. So if I press this resume, okay. So in my board, my push button is actually connected in the open drain method. Okay, just a minute. I'll connect to the Teams in my phone. Okay, you can see over here, my LED is initially in the on condition. Okay, so when I press this push button, my LED is off. And when I release it, LED is on. Press it off and on. Okay, this is because my push button is actually connected in the open drain process. Okay, so what I need to do is I'm just going to make this state as 0. Okay, so initially it will be 1. If I press it, it will become 0. Okay, so I'm just going to build this and debug. Switch. Okay, so if I click resume, now you can see my LED is in off condition now. Okay, so when I press this push button, my LED is on. When I release it, it will be off. Okay, so this is on and off. Okay, so this is for the inbuilt push button. Okay, so simple code is just 5 lines of code. Okay, not 5 lines actually, it's just 3 lines of code. One is for read pin and write pin, 2 write pins. One is for set and reset. That's it. So if you made that, your GPIO pin will work. Okay, so those who are having board, try this one. Okay, for those who don't have a board, I'm just going to create a new project for the work week. You just follow this method. So file new STM32 project. Okay, so this is for favorite. Okay, so board is not here. I'm just going to type Nucleo. Sorry, here I need to type STM, right? So STM 32 C031 C6 T6. This one. Okay. So I'm just going to select this board for the workview simulator. So this is for push button workview. Okay. So before writing that, I'm just going to make this connection in workview. STM32, and this is C0 Scratch project. Okay. So here I'm just going to make the connection. So what are the things I need? I need an LED resistor and a push button and another resistor for the push button. So this is for LED, and we'll be having one resistor for this one and a push button and another resistor for the push button. Okay, so where I'm going to connect, this is PA5, this one. Okay, so I'm just going to flip this, and my anode pin will be connected to PA5. Okay, and my ground pin will be connected to this. Okay, so this is for an LED connection. And for the push button, okay, so this one I'm going to connect, let's say PB13. Okay, is PB13 available here? Yeah, PB13. Okay, so this is for PB13, and I'm just going to connect this with the ground pin. Do we have a ground over here? Yeah. So I'm just going to take this and connect it to ground. Okay. And this pin, I'm going to connect it to plus 5 volt VCC. So this is my plus 5 volt. And this is for the 5 voltage. Okay. So I hope you people know this push button connection. Right? You people know this, right? Or do I need to explain it? Anyone? Do you know the push button connection? Yes, anyone? So I hope you're clear. Okay. So I'm just going to exit this full screen. So I have connected my push button to PB13 and my LED to PF5. Okay. So here I'm just going to connect my PF5 to GPIO output and PB13 to GPIO input. Okay. And then I'll just make this high speed Here we have a nice pitch ceramic clock, I think so. Okay, and okay, I'll just make it bypass, and this one I'll connect it to crystal ceramic. Okay, I'm just going to generate the code for this GPIO alone. Okay, so if I go over here with this GPIO, now you can see this is for A5 output and this is for B13 input. Okay, so I'm just going to copy this entire code and I'm just going to delete this file. This is new file for main.c and similarly a new file for main.h. Okay, so in main.c I'm just going to paste this, and in main.h I'm just going to copy the main.h and I will paste it here. Okay. Yeah. So here in this user code 1, I'm just going to copy the previous main.c file, this code, and I'm just going to paste it here. Okay, so here it is PB13, yeah, and this is A5 and everything is same. Only this PB13. Okay, here it has to be 1. Okay, because here we didn't connect an open drain method, so it has to be 1 here. Okay. Yeah. So if I press this push button, my LED will be on. If I release it, is it stuck? Yeah. So if I press on, release off, press on, release off. Okay. Again, there might be some issues here. Okay, press release. Okay, so this is what the circuit for the Vokvi and the code. And those who are having hardware, you just select this one and then try it. Okay, so copy this code and circuit. So let me know once you've finished this one. Okay, we'll go for the bare metal programming.
Sir, hello.
Yes, Yuvraj.
Yeah, actually I completed, but that output is not coming. There is no error in the program also.
Okay. For the workway or for hardware?
In hardware.
Okay, what is the error?
No, there is no any error, but if I press the button, it is not doing.
It is not blinking. Okay. Can you share the screen and show me the code?
Yeah.
Yeah.
Are you able to see my screen?
Yes.
Oh. Only the code I have written and no error.
Okay.
And I have one more doubt that
Yeah.
my code PA0 is also mentioned. Like is also the one of the
Which one?
this one. Yes, in P1 user button, PA0 or PC13. Which one we need to use? By
Uh,
default, it is
no,
mentioned
by
that
default it is
PC13.
PC13 only. Okay.
Yeah,
Tamper support. Okay, which version is it? G4.
G4.
Okay. Okay. Mm, just a minute. We will see. Can you tell me the exact number? STM32. It's
G4.
nuclear board, right?
Yeah. Okay.
Nuclear G4
91 RE.
RE. Okay. Just a minute. Let me check. Is there any schematic diagram? Okay. Installing user button V1 is connected to VDD directly. Okay. Okay, that is PC13 only.
Oh. Yeah,
Yeah.
now it's okay.
It's PC13 only.
No, no,
Okay,
now it is working.
it's working. What you did?
Yes.
You didn't run the code.
Actually, previously I make it this set
1 and
means
0.
I put at one as
Okay,
1 0 I put, but it's not working.
You can put
But
high.
that is also it's okay, right? It's one
Yeah,
means we
you can
can
put high and low also. Can you try with high and low?
I
Yeah, high HHGH.
small
Capital,
or
capital,
little.
capital, all capital. Build the code first. It's showing error. Okay, so it is either set or a reset, or 1 and 0 can be
But
given.
1
Okay,
and 0,
yeah,
there is no any error showing. But
you can give
yeah,
1 and 0 also. Give 0. Okay, now build the code.
yeah, working.
Okay,
Maybe
okay.
I didn't saw correctly.
Mm-hmm.
Okay,
Yeah,
thank you.
okay. So others, have you got output, or is anyone facing any issues? Okay. Yes. Okay. So shall I go to the next program for the bare metal? Okay. So I hope you all finished. If anyone wants me to wait, just let me know. Okay. So before that, bare metal, I need to open all these documents. So first one, I need to open the data sheet. So this is my data sheet. Okay. And next I need to open my reference manual. So this is my reference manual. Okay. So now for the same inbuilt push button and LED, okay, I'm just going to see the data sheet. Right. So as like my previous GPIO, this one is also connected to my ASP decoder only. You can see over here. This device is actually connected to AHP. Okay, my port A as well as my port C. Both are connected to AHP decoder only. Right. And okay, just a minute. I'll connect my writing pad. Yes, okay. So here you can see my GPIO port A, that is my PFI, and also my PC13. Both are connected to my AHP decoder only. Okay, that is, this is my AHP bus. Okay, so it is connected to AHP. So what are the three steps? First step, I need to set the RCC clock. Okay, that is my first step. Okay, and my second step, I need to enable this GPIO, that is an input or an output. Okay, so once again, I'll write it in the first page. So my step number one is I need to set the RCC for the GPIO A as well as GPIO C. Okay, so A port is connected to different register and C port is connected to different register. So I need to set both these things first. And second thing, I need to set the mode for the GPIO. Okay, so that is my LED is output. Okay, and my push button is an input. Okay, so I need to select this one as something like an 1 and 0. So this one I need to select 0 0 for input. Okay, so that we will see in the register, no issues. So that is my second. And third thing is I need to check the status of push button. Okay, and based on that, I need to set or reset the LED based on step 3. Okay, so these 4 steps I need to follow. First, setting the clock pulse for the GPIOs. Then I need to select the mode, that is output mode or input mode for the pins. Okay, and I need to check the status of that pin. Based on the status, I need to select whether my LED has to be turned on or my LED has to be turned off. Okay, so these 4 steps I need to follow. Okay, now I'm directly going to this reference manual. What is the first step? First step is I need to go for this RCC, right? So this is my reference manual. So I'm just opening this table of content. Here is my RCC. Where is my RCC? Yeah, this one. And RCC register. Okay, I'll directly go to AHB. Okay, so this is my AHB. So last program, what we did is we just configured only one port. That is this GPIO A alone, that is IOPA, that is input output port A enable, only this. But this time I need to enable this one also. Okay, so first is for the port A, second is for the port B, that is 17th pin and 19th pin. Sorry, 19th bit and 17th bit. Okay, by this RCC AHP enable register. Okay, I just need to make this one left shift for 19 times, one left shift for 17 times. That means I'm assigning the clock pulse for these 2 pins. Okay, that is step number 1. Okay, now what is my step number 2? Step number 2, I need to directly go to this GPIO. Okay, here this is my GPIO register. This is my mode register, mode enabled register. Okay, now in this mode enabled register, first thing is I need to set for 2 mode enabled registers. Okay, first mode enabled register will be GPIO A, arrow mark, mode enable. Okay, so this is for PA5. So this is this particular 10th bit and 11th bit has to be 0 and 1. Okay, so this has to be 0. This has to be 1 for making it an output. Okay, now if my GPIO C is an input, mode enabled register. Okay, my GPIO C is connected to PC 13, right? So this is my 13th pin. Okay, which is nothing but 26th bit and 27th bit. These 2 bit I need to enable. Okay, since it is an input, what is my state for an input? It is 0 and 0, right? So I need to make this 27th bit and 26th bit as an 0. Okay, so this one 26 and 27 as 0. Okay, here I need to make the 11th bit as 0 and 10th bit as 1 in order to make it as an output, and this is for an input. Okay, so first I made the thing that is the clock pulse has been enabled for all these registers. Okay. And then I set the mode. This is I'm going to use it as an input mode. This is I'm going to use it as an output mode. Okay. Now for the output mode, I use something called as an ODR. ODR is an output data register. Okay. Now for an input mode, I need to use an IDR. IDR is an input data register. Okay. So where is my pin is connected? My pin is connected to 13th bit, right? So I need to check whether my 13th bit is 1 or a 0. Okay. In our case, 0 means on, 1 means off. So I need to check this particular pin is 0. If it is 0, then in output data register, I'm going to make this 5th bit as 1. Okay. So this is what we are going to do in our program. Right. So setting clock pulse, assigning the mode, and then checking the input data. And based on this input data, I'm going to set this output data register. Okay. So these steps we are going to do for the bare metal program. Is it clear? Any doubts? Or is anyone
It's clear, sir.
wants? Okay. If anyone wants to repeat, just let me know. I will repeat it once again. Because based on this, we are going to write our code. So just let me know. Shall we go to the code? So I hope it is clear for everyone. Okay. Right. So here I'm just going to create a new project. Just open. Okay. I'm going to select this microcontroller or microprocessor selector to this one, F334. Okay. Click next. And here I'm just going to make okay, push button underscore bare metal. Finish. And it will open the IOC. For bare metal, I don't need this IOC file. Okay. So I'm just directly going to close it. So this one I'm just directly going to close. So this is okay. I will just close this workv file and also this push button. Okay, I only need this main.c, and that too my previous file is not needed. Okay, I'm just going to write a fresh code. Okay, so that's what in bare metal, right? Okay, so my first step is I'm just going to include the header file. So ash include stm32f334 x8. Okay, so this is my header file. Okay, after that int main. Okay, so what is my first step? My first step is setting the RCC for GPIO-A as well as GPIO-C. Okay, this is my step number 1. So my GPIO-A and GPIO-C is connected to AHP register. So I'll directly go to this RCC registers AHP register. Where is AHP? This is GPIO. RCC AHP peripheral. Okay, this is my AHP register. So the 17 is for A port and 19 is for B port, right? So I need to set these two first. So here, okay, what is the register name? Register name is RCC AHP enable register, right? So RCC hyphen, this is AHP enable register. Okay, so I'm just going to make it as an R equal to 1 left shift 17 times. Okay, so this is for setting or enabling GPIO-A. Okay, since GPIO-A is in 17th bit, I'm just making this as 1. And similarly for the 19th bit also. So RCC enable register, this is for 19th bit. I'm just going to make is 1 for the GPIO-C. Okay, so why C? Because my push button is connected to C port only. So this is for C. Okay. Is it clear till now?
Yes, sir.
So the next step is setting this PA5 as output. Okay, so that is my next step. So for that, I need to go for this GPIO register. Okay, so I need to select this mode register, right? So first one is GPIO A, this mode enable register. Okay, I need to make this mode enable register 10th pin and 11th pin as, sorry, 11th pin and 10th pin as 0 and 1. Okay, that means 10th pin has to be 1 and 11th pin has to be 0. So for that, I'm just going to make this 1 left shift for this is 1, right? So 10th pin. So 10th pin has to be 0 and my 11th pin has to be 0. So for that, I'm just going to make an AND operation with the negotiation. Okay, so that means 1 for 10th bit and this is 0 for 11th bit. Okay, so 1 and 0. Now, can you tell me what is I need to set for this PC13 as input? I'll just put GPIO-C of this mode enabled register. Okay, I need to set both these pins as what is the value? What value I need to set for
0,
an
0.
input? 0, 0. Okay, so my 26th bit as well as my 27th bit has to be 0. Okay, so I'm just going to put an AND logic, bitwise AND equal to this negation of 26th bit and also GPIO-C 27th bit. Okay, so both are 0. 0 for 26th bit. Okay, and similarly 0 for 27th bit. Okay, so till now my configuration part is done. So I have set the clock and I make this as output and this as input. That's it. Okay, so now I'm going to write my actual code, which is nothing but inside my while of 1, that is inside my infinite loop. Okay, so while of 1, if, okay, I need to check my input data register is 1. Okay, so this is what I need to check if my input data register is 1 or not. Okay, that is what I'm going to check. So for that, I need to set this is GPIO A, right? Okay, so GPIO C. So GPIO C of IDR. Okay, I'm going to do an AND operation with one left shift for 13 times. Okay, so this pin I'm going to check. Okay, if ampersand of this, that is this IDR and this 13th bit, if this both are 1, then I'm going to turn on my LED. Okay, that is what this line says. Is this line clear?
Yes, sir.
Okay, for others, is this clear? Or do I need to
Yes,
repeat
sir.
it again? Okay. Okay, but in our case, what will happen? This pin is connected to open drain method. So that means if I press, it will be 0. Okay, so for that, what I'm going to do, I'm just going to put an not symbol over here. Okay, that is, it will be 1. If it is not 1, that means if it is 0, then turn on my LED. Okay, so that's what I'm saying. Right? So for turning on LED, what should we do? We just need to make this ODR register, this 5th pin as 1. Okay, so for that, yeah, here I'm just going to put in GPIO A of ODR register. Okay, here I'm just going to put in R equal to 1 left shift for 5 times. Since it is PF5, okay, I'm just going to make this ODR turn on. Okay, so this is for turn on LED. Okay, so this is for checking the status of push button. Okay, or else what will happen? I'm just going to turn off this LED. Okay, so that's it. So for turning off this LED, the same thing, but we just need to make an AND operation with the negotiation of this. Okay, so that's it. Here, this while of one part. Okay, because after this program, you people have to try with 2 LEDs. Okay, so and two push buttons. So you people have to work that out. So make sure this is clear. This is clear, right? Or do I need to explain it again? This part?
Clear, sir.
Okay. Yes. So now I'm just going to build the code. Is it finished? This is done. This is done. This. Okay. This. Okay. Yeah. So it is 0 error and warning. So what I'm going to do, I'm just going to make it in the debug mode. Sorry, I need to connect it. No. Okay. Switch. Okay, I'll click resume. Okay, so I'll show the code, show the video. You can see if I press this button, it will turn on. If I release, it will be off. On, off. Okay. So we can simply do this within something like 25 lines of code without the spaces and everything. It is just a 25 lines of code. So this is what in bare metal is. Okay. I'm just going to copy the same thing and in this workv, I'll create a new one.
So can you paste it in group also? Maybe it's easy for us.
This one, this code.
Yes, code.
Okay. Only the bare metal or the HAL also?
Bare metal, bare metal.
Okay. Just a minute. I'll just make it main.c. Yeah. Okay. So this code you need, right? This is push button bare metal. Okay, I'll just put this main.c file in the group.
Sir,
Yeah. Yes, what happened? Someone called me, right?
சார் எனக்கு கொஞ்சம் சென்ட் பண்றீங்களா சார் கோடு?
Okay. So I'll just this is my push button bare metal. Okay. Saravanan. Saravanan இதுதான் உங்களுது. Okay.
ஆமா சார். தேங்க் யூ சார்.
Okay. So in workv, what we are going to do, we are just going to make this f c03. I think c0x6. I think it will work. Or c031x6. That is it. Not this, not this. System 32C0. Sorry, not this. This is C0XX. Okay. The only thing is I just need to change this to C13. Let's see where this C13 is. Okay, this is C13. Yeah, I'm just going to remove this and I'll connect the C13 here. So here I'm just going to copy and paste this code with run. Mm, PC13. Okay, this one. This is 13th pin only, C13. Yes, C13. Free on is fine. Why the status is not changing? Is working. Can you even try this with workview and tell me whether you're getting an output? Because here I didn't get the output. I'm only getting the single state. This is not checking this pin. Okay, can anyone try this with workview? The same PA and PC13. Okay, and then check and let me know whether you are getting an output. For the hardware, have you got an output for hardware?
Yes, sir.
So those got output, try this program. I'll tell you, try this with the bare metal, okay? Mm. So this is my condition. Let's say I'm having 2 push buttons and 2 LEDs. So this is for those who got output. Okay, try this one. And 2 LEDs. So 2 push buttons are connected in one is connected in PB0 and the next one is connected in PC13. Okay, so LEDs are connected in, one is PA5, okay, and the next one is connected in B10. Okay, so these two are my LEDs, these two are my push buttons. Okay, so my condition is if I press PB0, okay, so if my PB0 is pressed, then both PA5 and PB10 should be on. Okay, if my PC13 is pressed, both PA5 and PB10 should be off. Okay, so this is what my condition. Can you try this? Those who got output, try this one. And if you finish the code, just put it in the chat box. So I'll see that. Is the question clear for everyone?
Okay.
Yeah, try this one. Yeah, has anyone finished this one? It's two button and two LED. Has anyone tried?
Facing one errors.
You're facing error.
Yeah.
In bare metal.
Yes.
So this code.
Oh, it is old code. This one I will say.
Okay. Can you share your screen?
Yeah.
Yeah.
We are able to see the screen.
Okay.
In this area, I'm getting expected semicolon for the place.
No, else if has to have some spaces. Else space if. No, else space if. Okay. Run.
Yes. Then I don't have extra LED.
And also you need to put one more bracket because see the first bracket is for
Where is?
no. That else if I think. Wait. Okay. One more bracket for that. You are actually checking two different conditions, right?
Yes, sir.
Okay. So one condition has to have a bracket, a separate bracket. That means that has to be executed first. Yeah, open it there and close it before the double ampersand. Okay, so that is one thing. And similarly here also, after the double ampersand, no, on top itself, line number 22. So similarly,
Yeah.
you put for first condition, right? Similarly for the second condition also, you need to open and close one more.
So like this here also.
I think yeah, okay.
Actually, my board is different, so that.
Yeah, but the code is correct. Okay.
And also I put directly the register name. So
Okay. Yeah. Okay. So others, are you trying? What about Arvind, Augustine?
sir, that we have a shortcut for that command mode. Make it as command mode whole paragraph itself. That do you know that?
which one? The comment.
Yes. Make it
That is
comment for all at a
that
time.
is slash star for starting and star slash for ending. I'll put it in the chat box.
No, just I done this
Yeah.
here and then
Single star actually. Slash star and ending star slash.
I want to hear this
Star slash. No, not that one. Yes.
Yes. Okay.
Okay.
And for the continuous lines means like I want to do this only. I'll select and then need to do as a command means.
Just press control that slash.
Then?
Yeah.
Okay. Okay, sir. Yeah.
Similarly,
Any other shortcuts? And for alignment, if it is not aligned, we need to do it alignment.
for the indentation. For indentation, just select it and press tab. Select. No, it's not coming, right? Is it?
No.
I think you can't group and select it. Okay. No, it'll come. Select it. Press tab. Tab.
This alignment.
No, select it and press tab.
Selected.
Yeah, single tab. Tab. Yeah, it will go.
No, this one alignment time. I want it aligned in a single row. Okay, this one is going out right, so we need to be in a single row.
For that one, I didn't try actually, but this one I don't know because I haven't tried that one. Only this tab I have tried. Yeah, okay, others, are you trying? Okay. So others just try it, and if you have anything, just let me know in the WhatsApp, or if you want to send the code, just send me in the group or my personal chat. Okay. So this is what an GPIO, that is your push button and LED. You can try this with either a bare metal or HAL, whichever is fine for you. Okay. So, and next class we will see the ADC. Okay. So ADC we can actually able to try with two methods. One is polling method, and actually three methods. One is polling method, interrupt method, and DMA method. Okay, so polling method is your normal analog to digital conversion. Like your CPU will wait for the conversion from analog to digital. Okay, so I think I hope you have seen this one, right? Where it is, where it is. So you know the successive approximation method, right? For the analog to digital conversion. Just a minute. Yeah, this one. This part you know, right? The successive approximation method, how to convert an analog value to digital value.
Screen not visible, sir.
Screen not visible now. No, I shared it. Now,
Not yet.
visible,
sir. It's visible.
Yeah. So have you tried this method? I mean, have you know about this method? There's analog to digital conversion in the PIC microcontroller. No. Yes or no?
No, sir. No,
No.
sir.
Okay, then I will teach this successive approximation method in Monday's class. Okay, how to convert this. There are multiple methods for converting the analog to digital value. Like these are the dual scope, successive approximation, flash converter, binary converter, and all these things. So in that, most preferably we'll be using the successive approximation because it is fast and accurate, and also less cost as compared to this binary weighted. Um, and flash conversion is the most fastest and accurate conversion of ADC, but it is very expensive and it is large circuit. It requires large circuit, so I'll be mostly going for the successive approximation. I will teach you this how this method will convert an analog value to digital value, and in that I said a polling method, interrupt, and DMA, right? So polling method, what will happen? Your CPU will wait for this conversion to be happen. Okay, so it will get a value and it will wait for that particular amount of time until this conversion is finished. So during that time period, it will not get any other input from the devices, or it will not process any other instruction. Okay, so that is actually a wastage of resources, right, for your CPU. So what we will do, we will go for an interrupt method. That is, once you get an input, your interrupt will automatically start this conversion in the background. So during that period, your CPU can do some other operation. Once this conversion is completed, then you will print it at somewhere, whatever it is. Okay, so that can be done. And also DMA, same method. DMA, as I already said, it is an direct memory access. So your analog device will directly access the memory and it will do this conversion process. Okay, so we will see all three methods of ADC and how to configure the polling method, how to configure the interrupt method, how to configure the DM method. Okay, so all these three things we will see on Monday class. Okay, clear? So thank you and bye. We'll see you on Monday.
Thank you, sir.
Yeah, thank you. Bye.
Yes.
Sir,
Thank you, sir.
Yes, sir.
சார் இந்த பேரமெட்டல் ப்ரோக்ராமிங்க்கு எந்த மேனுவல் சார் டவுன்லோட் பண்ணணும்? ரெஃபரன்ஸா யூசர் மேனுவல்?
ரெஃபரன்ஸ் மேனுவல் டவுன்லோட் பண்ணணும்.
டவுட்
ரெஃபரன்ஸ்
இருந்துச்சு அதான் சார். ஓகே.
ரெஃபரன்ஸ் மேனுவல் வந்து இது எல்லாமே இருக்கும். ரெஜிஸ்டர் டீட்டெயில்ஸ் எல்லாமே.
ஓகே சார். அந்த நியூக்ளியோ F334 ரைட் இந்த
ஆமா.
மேனுவல் தானே சார்?
நீங்க எந்த போர்டு யூஸ் பண்றீங்களோ அந்த ரெஃபரன்ஸ் மேனுவல். இப்போ உங்ககிட்ட போர்டு இல்ல, நீங்க சிமுலேட்டர் யூஸ் பண்றீங்கன்னா இந்த C031க்கான ரெஃபரன்ஸ் மேனுவல் டெவலப் பண்ணணும். ஓகேவா?
ஓகே சார். இன்னைக்கு கிளாஸ் லேட்டாக தான் வந்தேன் இருந்து. ஸோ அதனால லிசன் பண்ணவே இல்லை சார். அதான் நான் கேட்குறேன். அதை டவுன்லோட் பண்ணி ஒரு டைம் பார்க்கலான்ட்டு ட்ரை பண்ணி பார்க்க.
சரி, ஓகே. இந்த ரெக்கார்டிங் எப்படி உங்களுக்கு லிங்க் அனுப்பிச்சிருவாங்க. குரூப்ல வந்திருக்கோம்ல லிங்க்.
சரி, ஆல்ரெடி லிங்க் வந்திருக்கு சார். 3 வீடியோ 3 டேஸ் கிளாஸ் வந்திருக்கு.
ஆமா. இது 4th டே கிளாஸ்.
ஷேர் பண்ணி.
அதை பாருங்க. ஏதாச்சும் டவுட் இருந்துச்சுன்னா கேளுங்க. ஐ வில் டேக்.
ஓகே சார்.
ஓகே.
தேங்க்யூ சார்.
டேக்.
ஓகே.
Okay, guys. Thank you. Bye.
Thank you, sir.
Bye, sir. Thank you.
Thank you. Bye.